Welcome to Education Online. My name is Danny Susan, your teacher of math. Today we're going to talk about logarithm. And for us to know more about logarithm, we're going to start by defining what logarithm is. With me here I have that the logarithm of a number to base x is the power to which x must be raised to give the number that is, for example, if we have m is equal to x to power a, we're trying to explain the definition in details. If we have a number like m is equal to x to power a, then what we mean by that is a is equal to log of x m. A is the power. When you look at this, a is the power of x, and x becomes our base and m becomes the number. So when we are working out logarithm and given a number like this, you need to know which one is the number, which one is the base, and which is the power, so that you can easily work it out. For example, now we've been given a log of x m. It's the same as when given number like 100 is equal to 10 to power 2. You need to know which one is the base, which is the number, and which is the power. So we're going to have some examples to help us. Then for after, we shall have the laws of logarithm that will guide us when it comes to calculating logarithm. So we are saying similarly, if given a number, for example, like 100 is equal to 10 to power 3, given a number like this, you know which is the number in this case, which is the base, and which is the power. The power remains the same, and our base is going to be base 10 in this case, and the number will be 100. So when given a number like this, when we write it in logarithm form, we shall have our log of 10. As we said, 10 is the base, and the number will be 100. And when you work this out, will give you the power, which is the answer as 3. So from here, let's have the laws of logarithm that will guide us to calculate worked examples of logarithm to help us understand how to work it out. We have very many laws of logarithm that is going to help us understand on how to calculate numbers given in logarithm form. So we're going to have, for example, the first law is when adding numbers of the same base, if we have like log ax plus log ay, when adding numbers of the same base, what we do to the powers, in this case the powers will be x and y. So when given a number like this one, when you're working it out and the numbers are having the same base, what you need to do is to multiply the powers. So we're going to pick log a and we're going to multiply the powers, which is x times y. Since both numbers have the same bases, so this strictly applies to numbers given on the same base. So for this case, the two bases are all a. So when you're adding numbers of the same base, you must multiply the powers, just like how we did it here. Let's have an example. If given log 2, 3 plus log 2, 8, when given a number like this, and remember we're having an example on our first law that when given numbers of the same base, we multiply the powers. So with this, you're now going to have, this will be our solution. We shall have log 2, 3 plus log 2, 8. And we said adding numbers of the same base, we are going to multiply the powers. So we're going to multiply 3 and 8. So we shall have this as log 2, and the two powers are 3 and 8. When you multiply 3 and 8, you'll have log 2. This will be 24. 3 times 8 is 24. So this will be our final answer. Shall therefore say we conclude our log 2, 3 plus log 28 will give us the final answer as log 224. Another example, if given log 2, let's use to another base. For example, log 10, 3 plus log 10, 2. When given a number like this one, what you need to do is simply multiply the powers. So what we're going to have here, since the bases are the same, we shall have log 10 3 times 2. When you multiply 3 times 2, you'll be in position to get 6. So we shall have here log 10 6 as being our final answer for this second example, which is log 10 3 plus log 10 2. We're still having example in our first law, which talks about adding numbers of the same base. You simply multiply the powers. Let's go to the next law, which is going to be on subtraction. Our second law says when subtracting numbers of the same base, we're simply going to divide the powers. So when given a number like this one, the two bases are the same, both to base A. This is base A and this is also base A. So when given a number having the same base and their subtraction, we are going to divide the powers. So in this case, we are going to have log A x over y. This applies only when subtracting numbers of the same base. So we are also going to have examples. And our first example, when given a number like log 2, 10 minus log 2, 5. When given a number like this, first of all, what you need to consider, the two bases must be the same. And if the bases are the same and the sign we are having is for subtraction, it means that the two numbers, the powers, we are going to divide them. You pick one base, which is now going to be, let's have the solution here. We shall have log 210 divided by 5. So when you divide 10 and 5, the two are divisible because both of them are multiples of 5. So we shall have log 210 divided by 5 will give us 2. And with this, both the base and the power are the same. So we're going to have here our final answer as 1. Let's go to the next. Let's have the next law, which is number 3. And it says, when given a number like log A x to power n, the number has got a base of A. We are having this number x and it has another number, another power, which is n. So when given a number like this, what you need to do is to drop the power, which is n. So in this case, we are going to have n log of A x. So when given a number like this one, it has another power. For you to solve it easily, you drop the power so that you can work it out before you multiply with the given power in the question. So let's have an example on this. Given a number as log 23 squared. Let's say this is our first example. This is an example to help us understand law number 3. When given a number like this one, we're going to have solution here. Our number, which is A, is log 2 3 to power 2. We said according to our third law, we drop the power being given, and in this case our power is 2. So we're going to have here 2 log of 2, 3 as being our final answer for this particular number. Let's have another example. If given log 3, 8 to power 2, we simply have this as, you drop the power which is 2, then log of 3, 8. Let's have the next law. Our next law says when given log a, your answer should be 1. When the number and the number being given are the same, your answer should always be 1. So let's have an example. For example, if we have a number like, our example A, if you are given log 10, your answer should be 1. Let's go to the next one, which is number 5. We're saying if given a number log A to number which is 1, your answer should always be 0. When given a number with the base 1, your answer should always be 0. For example, if given a number like given a number as log 10, 1, you should be in position to get 0 as your final answer. So these are some of the laws that are going to help us to solve given different examples of logarithm. So we're going to use these 5 given laws to help us to solve logarithm numbers. We're going to have some of the examples that will help us to utilize the laws accordingly to solve logarithm. So we are saying evaluate the following. And the first example is log of 2, 64. Here we've been given just a number which is 64. You may think it's the final answer, but when given a number like this, what you need to do is to factorize it. When you factorize 64, it can be in terms of 4, in terms of 2. But in this case, since we are having our base 2, we are going to factorize 64 according to factors of 2. So we're going to have it as when you factorize 64, we shall have log 2, 2 to power 6. 64, you can use a factor tree to easily divide it. For example, you can have your 64 here, then you divide by 2. We shall have 64 divided by 2, that will give us 32. By 2 here will give you 16. 2 as 3 divided by 2 is 1, remainder 1, that is 6. So by 2 here again you will have 8, by 2, this is 4, by 2, 2, and by 2 you finally get 1. So these are the numbers that you count to give you the power. So we have 1, 2, 3, 4, 5, 6. That is the power, implying 2 has appeared 6 times. That's why we're having 2 to power 6. So when we have a number like this, remember we said when given a logarithm with another power, what you need to do is to drop that power before the log. So we shall now have 6 log of 2, 2. And one of our laws says that when a number and the base are the same, it means our answer is 1, implying we are now going to have 6 times 1 to give us our final answer as 6. So we are saying, therefore, our log, which was given as log 264, should give you your answer as 6. This will be our final answer. Let's have the next example. We are still evaluating different numbers to help us. We are having the next one as log 2 3.2 plus log 2 10. Remember, our first law says when it comes to adding numbers of the same base, we simply multiply the power. So we're going to apply this here. We're simply going to, having solution to this number, we shall have our log 2 3.2 plus log 2 10. So with this, we are going to apply the first law, which says when adding numbers of the same base, we multiply the power. So we're going to multiply 3.2 times 10. When you multiply this, the 0 will remove the decimal, and we shall have log 2 32. 32 can be simplified further. I mean, you can factorize it into simple terms using 2. So we can factorize 32, and here we shall be having log 2. When you factorize 32, you will have 2 to power 5. So you continue, you drop this power, and we shall have 5 log of 2 to finally give you 5 times 1, and finally you will end up with 5 as your final answer. So the original number, which was given as log of 2 power 3.2 plus log 2 to power 10, when you work it out, your final answer should be a whole number. So let's have the next example. Our example, let's call it example 2. Say simplify the following. And our first example, which is example 1, says a half log of 1025 log of 1025 minus 2 log of 10x plus log 10 2x squared. So in this case, we are now being given letters in our question. We are having x here, and we are also having x here. So when we are working out, we should work until we get final value to the unknown. We simplify it further into simple terms. So we have a number like this. Let's start with the solution. Here we can see that the powers of the question have already been dropped. So what we need to do is to rearrange it by writing it as log 1025 to power half minus log 10x to power 2 plus log 10 2x. We have this, but one thing we need to know that power half is the same as the square root of a number. If you don't find it as a square root of 25, you can simplify and factorize 25 in terms of 5, and you'll be ending with 5 squared, so that the 2 can easily cancel out the power half. So let's use that because it will be much easy. So we shall have here log 10 5 squared times the power half minus log 10x squared plus log 10 2x. These two will reduce this one, so you'll be left with log 10 5 minus log 10 x squared plus log 10 2x. From here we can now start applying the first two laws, which is on subtraction and addition. We said when it comes to subtraction, when you're subtracting numbers of the same base, you have to divide the powers. So we shall start with the first, which is the subtraction, then we shall apply addition later. So here we're going to have log of 10, the two powers, we shall have 5 divided by x squared plus log of 10 2x. So now we have one single number. We've combined the first one using the law that concerns subtraction. Now we've got this as one whole number adding to this. So we are now having log 10 our number is 5 out of x squared plus log 10 2x. From here we're now going to apply another rule which says when adding numbers of the same base, you multiply the powers. So here we're going to we're now going to have it as log 10, we are having 5 out of x squared times 2x. This one is in a denominator, this is a numerator, so it can easily reduce the x. So here what we're going to have, our 2x are supposed to have a power which is to power 2 when you multiply. There is some bit of a mistake somewhere. I miscopied the question. I hope it does not change anything. So we shall have here squared. We shall continue whereby this will reduce with that. And finally we shall be left with log 10. We are having 5 here and this is 2. So we shall have 5 times 2 to give us 10. And when you have the base is 10 and the number is 10, our final answer will be 1. Hope you don't get confused. I simply forgot squared. This was supposed to be log 10 2x to power 2. So with that, let's have the next example. Our example 2 says, if log 10y plus 3 log 10x is equal to 2, express y in terms of x. So we've been given our question. Let's have a solution to the question and then we start working it out. We shall have log 10y plus 3 log 10x is equal to 2. Remember the bases are the same, but we are having a power here. So let's rearrange this and we shall be having log 10y plus log 10 x squared is equal to 2. The two numbers are having the same base and we are adding, but we are having 2 on the other side. We are equating to 2. So with that, we are going to do the apply the first rule, which says this is power 3. The first, which says that when you're adding numbers of the same base, you multiply the powers. So we're now going to have this as log 10 shall have y times x cubed is equal to 2. So when you have that, we shall have that is log 10 yx cubed is equal to 2. But as we started before, that when you have a number like this, you need to know which is the base, which is the power, and which is the number. So this is the same as us having our yx cubed is equal to the number which is 10 squared. 10 is the base, the 2 becomes our power, and our number is yx3. And our question is saying that we should express y in terms of x, implying we need to make y independent. So what we need to do is to divide x cubed on both sides so that we can be left with y alone, because the question asks us to express y in terms of x. So with this we shall have divide by x cubed, divide by x cubed on both sides. This will go, and you'll be left with y is equal to 10 squared is the same as 100 out of x cubed. And this will be your final answer as required by the question that express y in terms of x. You can see that y is equal to 100 over x cubed as being our final answer. Let's have the last example. Our last example, C says log 125 x plus log 125 5x is equal to 1 out of 3. So the two numbers are having the same base and we are adding. So what we need to do in this case, we are going to multiply the powers. So we shall have log 125 to power x times 5x is equal to a third. So when you multiply this, you'll be left with log 125 x times 5x will give you 5x squared. X times x, you get the x squared. This will be equal to a third. So with this, we shall also apply the same thing we started with about logarithm. When given a number expressed in its power is equal to a certain number, the way you express it in logarithm is the same. So when, for example, we have, like we had in the first example before, we had log of 10 yx cubed is equal to that. What you need to know is you write the number, you equate it to the base, then you put this as the power. So in this case, you are going to have our 125 to power a third, you equate it to 5x squared. So here we are going to express 125. You're going to factorize it in terms of 5. And 125 is the same as 5 to power 3. But remember, it is having power a third. You equate it to 5x squared. This 3 and a third outside can be reduced. You'll be left with 5 is equal to 5x squared. We want the final value of x, so we are going to divide both sides by the coefficient of x, which is 5. This will be by 5 by 5. Our x is still having a power, but we want the final value of x, so we are having x squared is equal to 1. For us to get the final value of x, we need to eliminate that sign, the square. We need to use the square root sign so that we can find the root of x squared is equal to 1. We introduce the square root sign to both sides. The 2 will cancel with the square root and we shall be left with x is equal to plus or minus 1. Whenever finding a root of a number, you should have two answers, positive and negative. And this will be our final value, implying we have our x as negative 1 and the other value of x is positive 1. Thank you. With this, we shall stop here for today. This remains Education Online and I remain your teacher, Madam Danny Susan.